One. Hello everyone, welcome back to another YouTube video here at The Construct. My name is Rodrigo Gonzalez, and today at Becoming a ROS Developer, we have one of our students, Hernando, who has completed our course ROS 2 Basics in 5 days. And at the end of this course, you can complete a project which you will implement on a real robot. So that's what we're going to be seeing here today. So hello, Hernando. How are you?
Hi, I'm good. So,
Great. So I'm excited to see your project. So whenever you want, you can please share your screen and just show us what you've done and how you solved it.
okay,
Awesome.
so I'm gonna share my screen now. Okay,
All right, I can see your screen now.
okay. Thanks for confirming. So, first I'm gonna build the wall follower thing. So, gonna start the.
Maybe while it's doing its thing, can you tell us what the wall follower thing is?
Okay, so in this project, I'm working with Turtlebot, which we are implementing a wall following thing. So we are imagining a scenario where we have a robot in unknown environment. So the easiest way we want to navigate it through the environment is to maybe we can try to find a nearest wall which it's performing earlier. So it's finding the nearest wall, and then at the first step, it will turn to it. And then at the second step, it will turn facing, so the wall is on the robot's right side. And it will start navigating through the environment guided by the right wall, which is it's doing right now.
Yeah, it's doing.
And what we're aiming here is we want to try to get one lap at least for this project. And here we are doing some recording also for how far it's traveling. So as you can see, we started right near the left screen, and
Yeah.
now it's approaching slowly but surely. Yeah, almost there. And at the end of the
Maybe froze a little bit, but that's all right.
Okay, so here's we see the robot is going back to its original position, and here is it's redoing. And yeah, so we got a lot of information here about the points of nodes that we go through. And if I scroll down a bit, I think we can find the total distance that it travels through is around, yeah, so here. So total distance travel is around 6.15 meters approximately, because we are not sure about the total length, but we know that the robot recorded at least 6.15. So
Okay,
I'm gonna
great.
change my share screen to presentation.
Yeah, awesome.
Okay, so,
we already saw it working perfectly. So yeah, this is what I was going to ask you next. If you could explain sort of how you solved these sections.
Okay, so based on the description that I just mentioned, so we have three things on the project. So we want the robot to follow a wall on the right hand side, and then we can when it starts, it wants to find the nearest wall that it can follow, and then we want to record the traveling distance. So the challenges is so first thing first is we're using a bit of a simple algorithm with no controller. So it's an open loop thing here. It's just using if else. If the robot distance is certain distance away from the right side wall and there's no obstacle in front, it can just keep on straight. And some challenges here is that the algorithm, since there's no controller, there's going to be a error. And I think we can see that in the when the robot is moving, sometimes it's shifted slightly to the left, sometimes it goes closer to the wall, and then it will slow down and corrects itself, and that's gonna cause a lot more error because since we're going a bit wavy, that's gonna add in more length or the total distance that we walk through.
Uh-huh.
Yeah, so that's the main challenges, and also those errors can come from the one thing that I know is that since we have a center of mass of the robot, it's not at the same or not aligned with the laser scan. So there's going to be a there's going to be an error in the measurement, which that can cause some issues with the or mismeasurement on the nearest wall. So that's the main challenges that I face. So the one thing that I do is I slow down the robot by a bit and make it to uh, have more time to process the measurement, and then we can get a better trajectory without putting in control. So that's just how I did it.
Okay. Um, Let me ask you. I see that you're done, right? This
Yep,
is
I'm done.
okay.
Mhm.
Okay, great, great. So nice control, smooth control there. Uh, Let me ask you some questions on these challenges. You mentioned
Mhm.
that the robot center of mass is not the same as the laser scan center of mass.
Yep.
What do you mean by that? Uh,
So they are not. So what I mean is, imagining like I'm the robot. So the center of mass is kind of like my heart. So my heart
yeah.
is at the center of my body, and the laser scan center of mass is kind of like my head. So my eyes might be slightly more forward
Ah,
position than my heart. So it's not aligned. And we want to know that the distance of the obstacle towards our center of mass, which is our heart. But since the sensor is our eyes, which is slightly more forward, there can be some displacement, some offset that can cause error if it keeps going to add in more if we keep continuous scanning.
right. I asked this because they're the same. At least,
Oh,
uh, well, maybe they're not, but they are close enough that they can be considered the same. Why? Why do I
mm,
say this? Because, all right, sure, it's higher up, the lighter than the actual, center of mass, which is actually represented by base link. The base link frame, it means that's where the center of mass is. You might also
okay.
see base footprint. That's the
Yeah.
projected center of mass on the ground. Um, but the laser is right on top. So the reason why I'm asking is, what issues did you run? Like, were you thinking that it was closer than it what actually was, or what were these issues that you're talking about? The nearest
Um,
distance, nearest wall. Would you
yeah.
crash basically?
Yes, so if let's say, because I started here with the position where there's the less obstacle. So I kind of like place it in a very ideal case where
Mm-hmm.
there's conveniently, if I turn a bit, there's a wall nearby. But if I place it like somewhere in the middle of the map here where there's a lot of cones, and
Yeah,
or maybe if I put it at the corner, which
you have
we
two.
have two different sides that can be equally equally close, and that might cause some issues to the program, and it might crash.
Okay, all right. So I understand. But it's important to know that, I mean, maybe I'm wrong, but that is not related to the center of mass, basically. So what you're describing here is, all right, I run it in a situation where it's gonna find the wall quickly. So that means you run it near the wall and you make sure it's not a corner or not the obstacles. The reason why I say this is that the issues you were encountering was probably that when you did your scan for the minimum value, which is, the instructions are, find the minimum value in your LiDAR and then turn towards it. That obviously, if you're near an obstacle, it's going to want to try and go near the obstacle. And if you're in a corner, it's going to go back and forth. Again, that's not related to your center of mass. Maybe you were crashing in a scenario in your center of mass because sometimes it's hard to understand between. So you think about the robot as a circle, and the distance that is red. My wall is a meter away. That is exactly from the center of mass, like you're saying. It's not from the edge of the robot. So the robot has a radius, basically, and that might cause you to misread those and crash. But I do not think, well, unless I'm wrong and the laser moved, I do not think that this center of mass is different from the robot than the laser. Okay? So it's good to separate those issues in your head, because then you can think about how you can solve, for example, the issues of trying to go to an obstacle that is the closest, or when you have two corners. For example, I can think of two things to avoid. Of course, this is not part of the project, but this is just to help with the understanding. For example, you can add a filter of some sort to determine whether what the minimum distance is either an obstacle or a wall. One thing you can use, for example, is statistics, right? So an obstacle is going to be a little tiny thing in this environment compared to the big, long wall. So how can you tell that to the robot? Well, you can take a big range, like 20 degrees or something. So you're looking at a section of the wall or the obstacles and some things. And you can look at the standard deviation of the values of that range, of that section of LiDAR. Now, if it has a really small standard deviation, that probably means it's the wall, right? Because you don't have a lot of deviation between every single dot. And if you do, you probably can assume, all right, that's an obstacle, so keep looking. And for example, that's one way. You can do it many ways. And for the corner, for example, you probably ran into an issue that, either the robot was doing this if you made it so it rotates both ways, or that it just kept spinning because it kept trying to find the minimum. So you can add, for example, if it's going like this, you can add a little detector that if the angular velocity, right, because you're turning either left or right, keep switching, you're in a corner, right? So do something about it. So that's what you mentioned about those two things. But you mentioned about the waviness of your path as well. And I don't think that's important for the purposes of this project. I think your movement was great and you didn't crash against anything. At this point, we don't care about how smooth it is. So as long as you did this with the if and else, that's more than enough. Of course, that will impact your stopped distance, which was like 6 point something. Let me ask you a question about that. Is it you ran it once, saw how much it was, and then stop it you record that distance and make the robot stop after that distance, or how do you make the robot stop? Is my question
Okay.
basically.
So to make it stop, so at the first part when we start the robot, we record the initial position. So the way we make it stop is that we make the robot move until it meets the initial position again, which is the same place that is originally is. So,
Oh, okay.
but we give it an extra condition, so it have to move for a certain range. So, because if we say if it's in the initial position, then it'll stop completely because
Right away. Yeah.
it's already there, yeah, right away. So we have to make it move for a while, for some amount of time or and some amount of time, and then after it came back, we can make sure that yeah, it kind of move, and we kind of pull a conclusion that yeah, it move around and it goes a full circle.
All right.
Okay.
Yeah. So in this case, you went even a step further than what I was asking. So because you could have just check the odometry, run it the first time, and be like, all right, the next time I'm gonna close it at 6 meters, and I'm gonna kill everything. And then you're checking the initial odometry to make sure when you're back,
Mhm.
it stops. All right, awesome, yeah, great. And then my last question here is just to cover the bases here. So because we want to specify what you can learn in the ROS 2 basics in 5 days. So I want to identify the three main things. So you have a service server, you have an action server, and you have a
Mhm.
normal topic subscribe,
No more time.
publish. Which one's which?
So the services is the finding the nearest wall. We want to find the way we find the nearest wall, and the action is actually is the recording of the odometry. So to record the initial position and then checking if it's already traveling and back to its initial position, and the normal topic, which is the just the wall following.
Mm-hmm.
That
Great.
is just it.
Awesome. Yes. I just want to add to that, to your action explanation, and provide feedback, because that
Oh,
is
yeah,
the sort of the benefit over the services. If we're going to
yeah.
think about it, a service server is like, I ask for something, I wait, and then I get a response. And an
Mhm.
action server is I ask for it, I do other things while I wait for the response and obtain feedback. All right. But yes, awesome, Hernando. Very quick, very concise, and I mean, I like how simple and straightforward your solution was. So congratulations.
Thank you.
All right. Uh, I think I don't have any more questions. So that is it for this presentation. So congratulations again. We're going to for everyone that's watching, we're going to start one right away after this with Hernando again for navigation. But we'll close it out this video to separate them. So I just want to invite everyone to do what Hernando did in his course. After completing it, you can obtain actually a certificate from us of learning, something that we take very seriously, and we need to see that people actually learned. So we require this presentation to give it out. So I really recommend to solidify your learnings that you took in this course, to go ahead and take a stab at this project and show it to us and see what you've done. But anyways, Hernando, thank you very much again, and we'll see you in a couple of seconds, actually, for the next one. All right. Bye-bye, everyone.
Right.